All right, welcome back to another video breaking down the weekly exam problems. So today we're going to be looking at these logarithm and exponential problems that we've looked at this week. So starting out with this first one here, the first step that we need to do whenever we're dealing with exponentials or logarithms is look at the numbers that are involved, particularly the bases, and see if we can write the two numbers, such as in this example, we can write these two numbers with the same base. So what we're going to do here is see if we can write this number here as 2 to the power of something. This one's also written as 2 to the power of something. So we'll just leave this side the same. And what we're going to do is we're going to realize that, okay, let's just revise our powers of 2. 2 to the power of 1 is 2, 2 to the power of 2, so 2 times 2 is 4. 2 to the power of 3 is 8. So we can see that 8 here is the same as 2 to the power of 3. So we can see that if we replace 8 with 2 to the power of 3, we get this expression here. And if we simplify that, what we have over here is based on the law to do with exponents that says that if we have a power raised to a power, we multiply the powers. What we can do over here is take that 3, multiply it by 2 minus x, and just remember that there are brackets here. We're multiplying the 3 by both the 2 and the minus x. So if we expand these brackets, this is going to become 2 to the power of 6 minus 3x. And over here we see that that's the same as 3x minus 3. And the only way that that's going to be possible is if 3x minus 3 is the same as 6 minus 3x. So we can write that out. 3 minus x, like so. So we've just equated the two powers because the bases are the same. All right. So next step, we just have here just a linear equation. So we need to now solve this for x. In order to do this, we need to collect all of the x's on one side of the equal sign and all of the numbers on the other side. So what I'm going to do is I'm going to plus 3x to both sides. So plus 3x to both sides like so. And what that's going to do is over here, we're going to have 6x take away 3 is equal to 6. And I've gotten rid of the 3x over here. And now I'll plus 3 to both sides. So now it's going to become 6x is equal to 6 plus 3, which makes 9. And final step is we just need to divide both sides by 6 over here. So therefore, x is equal to 9 over 6, which simplifies down to 3 over 2, which is the same as 1.5. So that's how we do that first one. All right, so moving on to the second one. We now have a logarithm equation. Now, as a general rule, if we have something that has logs or something that has trig stuff like sines, coses, tans, bring them all to one side of the equal sign and it'll make your life easier. So what I want to do is I want to collect all of the logs on one side of the equal sign. So to do that, I'm going to actually subtract log e of the square root of x from both sides, and I'm going to plus 3 to both sides. So I'm rearranging the equation like so. Sorry, is equal to positive 3. If I plus 3 to both sides, that becomes positive. All right, now we remember that if I have log base a of x and I subtract log base a of, say, y, that's going to be equal to log base a of x over y. This is one of those log laws that we should be aware of. So therefore, this expression here is going to become log base e of x over square root of x is equal to 3. All right, now how do we resolve this thing here? Well, what we can remember is that when we're dealing with square root of x is actually the exact same thing as x to the power of a half. So let's just replace this with x to the power of a half down the bottom here. And now what we have here is a division of two exponents. So here we have x to the power of a divided by x to the power of b. And to do that, we just need to subtract the two powers. So this is one of our exponent laws that we should know by this stage. So if we are dividing two bases, so two numbers with the same base and different exponents, we can subtract the exponents. So this becomes log base e of 1 minus a half. So 1 minus a half is equal to a half. So this becomes x to the power of a half is equal 3. All right, so now let's see if we can rearrange this. So what does this mean? Well, we're trying to find x. If in doubt when it comes to logarithms, it might be good to just convert between exponent and logarithm form to see if that makes things a little bit easier to work out. So to do that, the number that's the base will remain the base, and then we swap the other two numbers. So the number that's on the same side as the e will now be on the other side, and this number comes over here. So this number becomes e to the power of 3 is equal to x to the power of 1/2. This is using the definition of the logarithm. All right, now at this stage, we just need to get rid of that power of a half there. Just remember that this is the same as square root. So how do we get rid of a square root, or how do we get rid of a power of a half? Well, we can multiply both, we can raise both sides to the power of a half, to the power of 2. So if we raise this to the power of 2, we're going to get 2 times a half, which becomes 1, or we can remember that square and square root cancel each other out. And we're going to do the same thing over here, raise that to the power of 2. So therefore, we're going to get that x is equal to e to the power of 3 to the power of a half. And again, when we raise a power to a power, this means multiplying the powers. So the answer is e to the power of 6. And that should be the final answer there. All right, now moving on, we have this problem here. Now, this is probably the trickiest one here. There's a few ways that you can do it. What I would recommend is start by, again, like I said, let's just move all of the e's over to one side of the equation. So this is going to become 3et plus 8e negative t. So that's minus, isn't it? So if I subtract that from both sides, and I'll just bring the 5 over here as well, doesn't really matter too much. So I'm going to minus 5 from both sides of the equal sign. All right, so what are we going to do here? In fact, I'll leave the 5 by itself for now. So we'll just leave that over here. So what we can do here is see if we can take out a common factor. Now, this is where things might get a little bit challenging. If we try and take out a common factor of, say, let's say negative t, or let's say t to start off with. If I take out a common factor of e to the power of t, what are we left with? Well, factorizing, so I'm adding the brackets, and what we do is we take these terms and we divide them by that common factor. So if I go 3e to the power of t, that's going to leave behind 3. And if I go this number here divided by e to the power of t, now remember division means minusing the powers, so this will become 8e to the power of negative 2t. That's not looking so great. I want to create a quadratic somehow. So another strategy that we could use is to take out a common factor of negative t. So now what we're thinking, negative e to the power of t, sorry. So now what I'm thinking is, what is e to the power of t divided by e to the power of negative t? Well, remember, division means subtract the powers. So that's going to be equal to e to the power of t minus negative t, which becomes plus t. So that's going to be 2t, right? So this becomes 3e to the power of 2t, because that's 3e to the power of 2t. And then over here, if we divide this term by e to the power of negative t, that's just going to become 8, and we're left with this expression over here. All right, so that's our results. And I'll just get rid of all of this stuff here, just to make things easier. So we end up with 3e to the power of 2t minus 8 is equal to 5. Now, what do we do next? Well, we can see over here we have this e to the power of negative t. What we could do is we could multiply both sides by e to the power of positive t. Now, why am I doing that? Well, if we multiply by e to the power of positive t, we're going to get e to the power of t minus t. So when we're multiplying two numbers with the same base, we add the powers. So that'll become 1 over here. And then we're going to end up with 3 to the power of 2t minus 8 is equal to 5e to the power of t. And then what we can do is we can collect the like terms over on this side, or collect all the terms on this side of the equal sign. And what we have created here is a quadratic equation. So let's write this out. That's equal to 0. Okay, so how is this a quadratic equation exactly? Well, if we have a think about it, this is a quadratic equation in terms of e to the power of t. So we can write it in this form. So 3 times et squared minus 5 times et minus 8 equals 0. So just imagine our e to the power of t is like a, for example. So 3a squared minus 5a minus 8 equals 0. It's simply a quadratic equation. So how do we factorize this non-monic quadratic? Well, let's see if we can remember how to do that. What we need to do is first multiply the top and the first and the last number. So 3 times negative 8 is going to be equal to negative 24. And now we're thinking what two numbers add to give negative 5 and multiply to give negative 24. So factors of negative 24, factors of 24 are just going to be numbers like 3 and 8, and 6 and 4, and 2 and 12. And if we think about these numbers here, 3 and 8, we can use them to make -5. So what are we going to need here? We need to split this term here in the middle so that it becomes, we're going to make it, if this is -8 plus 3, they'll be equal to -5. So that works. So we'll have -8 e to the power of t plus 3 e to the power of t minus 8 is equal to 0. And now we can see here, just double checking, they are the same as each other. Yep, so -8 plus 3, that is equal to -5, so that works. And now we're going to factorize the two halves. So first up, looking at these first two terms, common factor is e to the power of t. So we'll take that out, leaves behind e to the power of t minus 8. And then these second two terms, they don't have any common factors, so we can just leave them in the brackets like this. And what we're going to notice is we have indeed created a common binomial factor, that common factor being 3e to the power of negative 3 times e to the power of t minus 8. So let's just come over here. All right, so what we can do is we can take out that common factor, write it outside of the brackets here. So we're going to create large brackets, take out 3e to the power of t minus 8, and leaving inside the brackets are going to be the coefficients of those two binomial factors. So they're going to be e to the power of t. And what's happening out here? Well, there's a hidden 1 next to those brackets. So this is going to be plus 1 equals 0. All right, so we've successfully factorized that quadratic, and I'm sure that there are other ways that you could have done this that were a bit easier. Another method you could have done is right from the get-go is just let e to the power of t equal a, and see what you can do from there. But so long as you can get to this stage here, then you're good. So now that we've gotten the question to this stage, we're going to now apply the null factor law, which states that this is equal to 0 if and only if that's equal to 0 or that's equal to 0, or they could both be 0. So let's consider the first case. So case 1 is 3e to the power of t minus 8 equals 0. Well, when will that occur? Well, what we can do is we can add 8 to both sides and then divide both sides by 3. That gets us e to the power of t equals 8 over 3. And if we write this in logarithm form, we have that t is equal to the natural logarithm, which is log base e. Just write it out like that. So log base e of 8 over 3. You could also write this in the form log e of 8 minus log e of 3. That's the way that your calculator will give you the answer. But either one of them is perfectly acceptable. Okay, case 2 is this thing is equal to 0. So e to the power of t plus 1 equals 0. So when will this occur? Well, what we need to do is we need to minus 1 from both sides, and then rearrange this and put it in log form. So this now becomes t is equal to log base e of -1. Now, the thing about log functions is that the input needs to be positive. So what we've written here is log base e of -1. That is actually undefined because the input into a log e function is only defined if it's greater than 0. So as y to the power of log base e x has domain x is an element of, or let's just say x is larger than 0. Okay, so that's an undefined answer, which means that this is in fact the only solution that your calculator will give you. So that there, I'll just circle it as our only possible solution to that first case there. So we would need, for full marks for this question, we'd need to find that other solution of log base e of -1 and then reject it because it's impossible. Okay, finally, question 2. So this question here, you could do it on a graphing calculator, but what we're looking at here is what's the maximal domain of this function? Well, let's just see if we can work it out algebraically without using a calculator. First thing I would do here is see if we can write this in factorized form. So we've got a quadratic. Generally, if you have a quadratic, you need to factorize it. Unfortunately, that's just the way it is. So this is a nice monic quadratic. We just need to find two numbers that add to give -2, multiply to give -3. That's going to be x minus 3 and x plus 1. So putting that into this form, we have this as our answer. Now it says find the maximal domain. So the maximal domain means for what values is this function here defined? Now what we know about log functions is that they're only defined when the input is greater than 0. So inputs must be greater than 0. Now, a few ways we can think about this. So that means that this thing and this thing both need to be positive, or this thing and this thing both need to be negative. That's one way of thinking of it. So we'll just do like this is the first way. So x both. So therefore, both are positive or negative. So if we consider the positive case, so positive case, that means that x minus 3 is greater than 0, which means that x is greater than 3, and x plus 1 greater than 0, which means that x is larger than negative 1. Now, notice that if a number is larger than negative 1, it's also larger than 3. So that means that if x is larger than negative 1, the function should be defined because both of the things are going to be positive. And we can also consider the negative case. So the negative case is that x minus 3 must be greater than 0 and x plus 1 is less than 0. If both of these two things are negative, we have a negative times a negative, which will make a positive. So we'll also have a solution. So for this one here, we're going to have that x is less than 3 and that x is less than negative 1. Now again, if a number is less than 3, it's also less than negative 1. No, other way around. If a number is... Sorry, that should be the other way around. So that means that the number needs to be less than negative 1. Then it'll be defined. If the number is less than negative 1, it will be defined. Because if it's less than negative 1, it's also less than positive 3. So in this case here, if it's greater than 3, it's also greater than negative 1. Sorry, this was the wrong way around. So therefore, we have this as our domain. So therefore, the domain is x. So x is an element of all of the numbers that are less than negative 1. So from negative infinity up to negative 1, not including negative 1, in which case it would be 0, and logarithm is not defined for a 0 input, union with 3 up to infinity. So this is our domain. Now, another way that we could have done this is we could have, so I'm going to draw a line down the middle here to indicate. So this was like a method 1, I guess. So method 1. If we consider method 2, what we could do is just think about what the graph of this quadratic looks like. So this quadratic, if we ignore the log part, this quadratic has x-intercepts at 3 and negative 1, right? And it's a top-down parabola that looks like that, has a minimum turning point. Now, if we know that the quadratic looks like this, then we can see visually, well, when is this quadratic positive? Well, it's positive for x values larger than 3 and x values less than negative 1. So drawing a picture like that in a tech-free assessment is also going to give us the same answer, and we can see that the other method we had to squint a bit and think about it. This method is much faster, so there's always more than one method to answer these sorts of questions, and one method is often better than the other. So in this case, drawing a graph is actually a superior solution because it's just faster. So therefore, we can see that the domain, well, I guess f only defines if this graph here, if x minus 3, x plus 1 is greater than 0. So we can see looking at this graph, it's greater than 0 for x values less than negative 1. And remember, when doing this, we have a square bracket around negative infinity. We list the smaller number first, so negative infinity is smaller than negative 1, union with 3 up to positive infinity. And that's our final answer there. And if you're curious as to what that graph looks like, it looks something like this. So we can see that The natural logarithm of x squared minus 2x minus 3 has asymptotes when x is -1 and when x is 3, and we can see it's undefined between those two values. So I guess, yeah, another way that you could have done this is written it as x is an element of R excluding the numbers from -1 up to 3 inclusive. In fact, these two ways of writing that final answer are perfectly equivalent, and if you'd written this, that's also a very valid answer. So that's the majority of what we've been looking at today. You can see if you use your CAS calculator, you can verify those solutions. So here they are. We use the solve function, and we're going to get back those same answers. All right, hopefully that cleared up any concerns or questions you had about those questions, and I'll see you guys next week. Have a good one. See ya.